do lesson 16.3 today. This is about interpreting the unit rate as a slope. Okay, you can follow along and go math if you'd like. As usual, I'm kind of skipping around, so it's up to you, but let's get started. So if you guys recall, right before we went on our little distance learning break, we had talked about proportional relationships. What we discussed was that in a proportional relationship, the change in the y values and the change in the x values, when you do y divided by x, you're going to get the same number each time. And that was called the constant of proportionality, right? I then told you that that would be the same as the slope. When you look at the graph, a proportional relationship is a straight line and it goes through the origin, right? So that's just a little review. So what we're going to do today is we're going to compare basically the unit rate and the slope. And that's to describe real world proportional relationships, okay? So the most important thing here is that the constant of proportionality for a proportional relationship is the same as the slope, okay? It makes sense. If the slope is the rate of change and it's constant, the constant of proportionality is also a rate of change that's constant. So they're the same thing. So for this first example, every 3 seconds, 4 cubic feet of water pass over a dam. Okay, so every 3 seconds, 4 feet of water pass over a dam. After another 3 seconds, 4 more pass over the dam. Okay, so what they want us to do is draw a graph. Now they've given us this table, and they want us to find the unit rate of the proportional relationship too. So, one way you can do that is to plot all these points, which is what they've done here. They did 3 and 4. This is going up by 2. 6 and 8. So that's here. 12 and 9. I'm sorry, 9 and 12. 12 and 16. And so on, okay? So looking from those 2 points, you can do the rise over the run. So it's going up by 2s, right? So this is 2, 4, 6, 8. So that was up 8 and then over 2, 4, 6. So that's how they're getting this 8 over 6. And then that can be reduced, okay, by dividing each one by 2 to 4/3. And that would be your slope. Now, as you can see, the unit rate, you've got 4 over 3, 8 over 6, 12 over 9. And when you divide all of those, they reduce down to the 4/3. So the slope is exactly the same as the unit rate, which is 4/3. Okay guys, I started doing this problem and Drew came downstairs to have breakfast. So I'm gonna redo this. Thomas rides his bike at a steady rate of 2 miles every 10 minutes. If you look at your graph, you can see that the time is the x, right? So the 10 is your x and the 2 is your y. So if you wanted to set up a table, x, y, remember x is always on top, I would just say take a look here because your 10 is all the way over here. So you want to go backwards pretty much here. So let's just say 10 and 2 here. So 5 would be 5, and if it's 10 every 2 minutes, then in 5 minutes, I'm sorry, if it's 2 miles every 10 minutes, then how many miles is it for 5 minutes? That would be 1, right? So obviously 0 is 0 and 0, okay? So you can graph those points together, 10 and 2. So this is 1, 2, 3, 4 here. And these are going up by 1s also. Okay, so 10 and 2. This is 10 minutes, 2 miles. And after 5 minutes, it's 1 mile. After 0 minutes, he's gone 0 miles, obviously. Okay, and we want to connect our line. Okay, hopefully yours looks better than mine because I'm trying to hold the camera at the same time. It's not working out too well for me. This is, as you can see, a straight line, or hopefully it is straight, and it goes through the origin, so you can tell that it's a proportional relationship. Okay, the unit rate, remember that's just when you figure out what the rate is for 1. So easy enough. We had our 2 miles every 10 minutes, right? So remember when we do our constant of proportionality, it's 2 miles every 10 minutes, correct? So if we reduce this, that means 1 mile for every 5 minutes. Okay, so our unit rate is that he travels 1 mile every 5 minutes. Okay, so as you can see, it ends up being the same as the slope. If I look at my graph, we're going up 1 over 5 to get to the next point. Okay, just to show you, when we did our constant of proportionality the other day, we were doing y over x, y over x, y over x, 2 over 10. This is 1 over 5, and every time you do that, it stays constant, the 1/5. Okay? Okay, guys, the final question. We're going to do exactly what we just did in that previous problem. We're going to compare the rates. We want to know, we have an equation, y equals 375x. Okay, that's our first one. And our second one is represented here in this table, okay? This is how the relationship between the time that a plane flies in hours and the distance that it flies in miles, okay? So this is plane A, and this one's plane B, okay? So we have to figure out what the slope of the graph for each one of the planes is and the rate of speed. So we're gonna figure out which one's flying at a faster rate. So plane A is super simple. We're not going to make a table. We know that the number before x, the coefficient, is the slope. So plane A is flying 375 miles per hour. Okay, now we have to figure out plane B. So in this case, we're going to use the table. So let's make our lives easier, and let's use these 2 smaller points. Ooh. Remember, we're writing them. X is on top, Y is on bottom. So the first point is 1, 425. That's point 1. Point 2 is 2, 850. Okay, and this is x1, y1, x2, y2. And the equation is y2 minus y1 over x2 minus x1. Remember, the y's go on the top, guys. So this is 850 minus 425 over 2 minus 1. Okay, so I want to give you guys a second, and you guys can figure this out in your calculators. Pause it, and then come back to see if you get the same answer as me. Okay, so we get 425 over 1, which means that plane B has a rate of 425 miles per hour. So plane B is flying at a faster speed. Okay, guys? So today's lesson of what you really need to take away is that the slope and the rate of the unit rate and the slope are the same. Okay, the constant of proportionality is your slope. Okay. Just the reduced form of it, of course, right? So when you fully simplify your constant of proportionality, that's your slope and your unit rate. And then finally, to compare 2 unit rates or 2 slopes or rates or anything in an equation, we know it's the number before x. From a table, we can use the y2 minus y1 over x2 minus x1. And from a graph, we can use rise over run. And that's it. All right, guys. Good luck doing your work. Have fun with it. If you're having any trouble with the amount of work, just let me know. We're all working through this together, so it's okay if you're having a tough time. Just let me know, and we can be flexible with it. All right, guys. See you tomorrow.